Aurora sells itself as Postgres-compatible, and at the SQL level it is, but the storage architecture underneath, completely different. That rewrites how checkpoints work, how replicas behave, and how failover happens, and it catches people off guard.
So it's not just managed Postgres, the engine itself works differently?
Right. The compute layer still speaks Postgres, but the storage layer is Amazon's custom distributed system. Let's look at what that actually means. In standard Postgres, the primary writes both data pages and wall to local disk. Every update writes wall immediately. Every checkpoint flushes dirty data pages. Replicas receive wall and replay it to reconstruct the same pages on their own disks.
Right, so the replica's disk ends up with the same data files.
Exactly. Both primary and replica maintain full copies of the data pages. That's a lot of I/O. Aurora flips that model. The primary writes only Bell records to a distributed storage layer, 6 copies across 3 availability zones. The storage nodes themselves apply the log to reconstruct data pages on demand.
So the primary never writes a full data page to disk?
Correct. No checkpoint I/O, no full page writes. The primary just streams log records, and storage does the rest. That cuts network traffic by 7x compared to replicating full pages. Because the primary doesn't write data pages, checkpoints in Aurora are just metadata operations, updating the storage's durable LSN. There's no dirty buffer flush, so checkpoint, timeout, and max wall size don't control I/O storms the way they do in vanilla Postgres.
And replicas?
Replicas are just additional compute nodes reading from the same distributed storage. They still replay well for in-memory state, but there's no page write lag. Storage already has the pages. Failover is a pointer swap. The new primary mounts the log and continues. Crash recovery is nearly instant because the log is already durable and applied. By the way, my DBA's free health check is Aurora aware. It monitors replication lag, flags inactive slots with the exact drop SQL, and tracks WEAL archiver health across both vanilla Postgres and Aurora topologies. In vanilla Postgres, you tune checkpoint timeout, max wall size, and shared buffers to balance checkpoint I/O. In Aurora, those settings exist but matter way less. Checkpoints don't flush pages. You also can't use PG-base backup to clone a replica. Aurora provisions replicas via its storage API.
So tools that assume local disk or measure checkpoint write rates won't make sense?
Right. Metrics like buffers, checkpoint, and checkpoint write time are near zero. And because storage is managed, you can't directly control page-level durability settings like full-page writes. Aurora's storage handles that. It's still Postgres at the SQL layer, but the I/O model is fundamentally different. Here's PG-stat-BG writer on vanilla Postgres versus Aurora. In vanilla, buffers checkpoint is in the millions. Every checkpoint flushes dirty pages. In Aurora, it's 0. The storage layer applies well. The primary never writes data pages.
So if I'm tuning checkpoint completion target to spread writes, that's irrelevant on Aurora?
Exactly. It won't hurt, but it won't help either. There are no checkpoint writes to spread. Your I/O tuning shifts from checkpoint settings to connection pooling and query efficiency. Whether you're on vanilla Postgres or Aurora, my DBA's free health check gives you a continuous growing report, graded A to F across 16 domains with exact runnable fixes. Connect your database in minutes, and the first report lands almost immediately. It deepens over the first week and keeps coming every week after that.
Where do we sign up?
Head to mydba.dev, connect your database, and you'll have your first health check in minutes. It's free, and it's built for both vanilla Postgres and Aurora.